So how many of you have experience with Kubernetes, microservices? All right, so we are on the right meetup, okay. Okay, so I actually had this series last year as well, which is why this picture is a little familiar to Paul. I had done a talk on how I stopped worrying and learned to build microservices with observability. And this is about how to scale microservices. So who am I? I'm an observability specialist. I also work in OpenTelemetry. I used to work at Observe and Neuralink. So I've been in the observability space for some time, and I'll start off. I actually use this even the last meetup because I love this. I used to read the Uber engineering blogs back in the day when Uber was the hottest company, right? And everyone was following Uber's growth and all the drama around it, and I mean, this was one of those most in a period of I think maybe 3-4 years they just had an explosive growth, and they documented this very diligently, right? So the blogs are excellent source of information. So even I think maybe more than 10 years back they had this diagram, and it was obviously oh wow, they have when you hail a ride, it goes through so many components, and so they had I think over 2,000 at that point in time. And yeah, so it's a very old picture. If you read up new ones, I'm sure. And those were the days where people were following, Netflix and Uber engineering, and everyone trying to follow and failing. That's a different, people trying different things on mobile applications and so on, right? So the net of this is microservices are complex, and people have now all accepted it, and they're all building it, and the infrastructure is equally complex. And this is again a sample diagram. I actually just picked it up, so definitely not Uber's architecture, but this is just to represent that okay, there are a lot of infrastructure components that a modern application uses. It just has some pictures to give you an idea that Kafka is everywhere. You will have load balancers, Elk stack, databases, multiple. It's not the old world where you have a cluster of database, cluster of app servers, web servers. There is a whole bunch of components, and they are not just deployed by an ops team, built by a dev team. So it's a different world, right? And we are all living it. And I put a picture of AWS here as a kind of another representative architecture, and I just have some components which might be familiar, but essentially these are hard to build, hard to write, and everyone is using containers. These are all kind of the default Lego blocks that we all use. And if it doesn't, are you guys using these things? Or, am I just making up things? Okay. So container-based applications running on clusters, right? So you have AWS has lots of services. Azure has some. GCP has some. They all have. They give you services. They have managed services. They have ways of scaling up and down. So that's what we all use, right? I mean, if you are a reasonably big company moving towards cloud, and it's again given everyone is moving there. So event-driven microservice architecture need container-based runtimes running in a cluster, right? So this is straight out of the Kubernetes documentation. It's again a representative of the cluster where you have nodes and pods, the control plane, and these are all things that are all worth multiple talks, right? And we are in the Kubernetes meetup. So how do we scale up? And scale up is actually also not a very good terminology anymore, because you have up and left, right? So you have horizontal scaling and vertical scaling. Just to, I had some speaker notes on these, but I don't think I need them for explaining this. Horizontal is, you have similar pods or same pods, just having multiple versions as you need, either your latency is, your latency is going up, right? Or your request per seconds are coming in faster, you need more pods, right? So you're actually, horizontally scaling. You're adding more resources. You're adding more nodes with more pods in it. As opposed to vertical, where this is kind of the old school way of doing it, where you added more CPU memory. We are way past VMs and all of that, right? So actually, there is also this whole thing of bare metal coming back, but that's a different talk. So vertical scaling versus horizontal scaling, right? I just wanted to bring this up because from now on we're going to talk about horizontal scaling, HPA, because KEDA uses HPA. So we already established that you need some sort of a good scaling mechanism, right? Which is why we are using Kubernetes or any container orchestration engine, right? So we use the containers to, so you write applications, you build them, you create containers, you have orchestration with either you have your own orchestration on bare metal, or you use a distribution in EKS or AKS. So lots of points of failures and lots of dependencies. So the scaling has to go beyond CPU and memory. I think that's kind of the main thing to come to here, right? So the default in Kubernetes and all the scaling is CPU memory. So if you have memory pressure or CPU pressure, it's going to try to start more based on what you specified in your deployment. And let's say you have, not let's say, there is a likely you will have some external dependencies where there is some event stream that you're injecting a whole bunch of things, right? So you have CPU memory that is running, and there are other pods that are picking up these event streams. So you have to be able to react to that, right? So the scaling has to go beyond just the CPU memory, and you have to look for metrics that are outside of the basic CPU memory, and that is where KEDA comes in. So KEDA is Kubernetes Event-driven Autoscaler. Okay, so we got that established in 10 minutes. That's good progress. So that's a lot of, we have a whole bunch of things behind it, but yes, this is where we are. So, HPA, we already talked about HPA, which is something we have in Kubernetes. So HPA uses CPU memory, and it adds, removes, based. So if you need more resources, it'll add pods. If you don't need, it'll remove pods. And this is exactly what the cloud, any elastic, scalable infrastructure does, right? So yeah, we already, so this is an example that I kept that picture again for to make sure that I talk about it. So if you have a Black Friday scenario, right? You have lots of people buying or orders coming in through the web, and you have Kafka queue or some sort of messaging system. You want to be actually having, you need more brokers, you need more consumers to pick it up, and you might want to funnel it to 5 different places, some analytics, some processing, some inventory, and all of that. So so they're all chugging along, and CPU memory is doing good. But you can anticipate based on the how the Kafka pressure is coming, right? The count of messages coming in, or count of things that are in the topics, and so you can scale up and down. So there is scalars for Kafka, scalars for MongoDB. Yeah, I'll talk about all of that later. But that's a scenario that is very common in any modern application, and pretty much I think every cloud environment, cloud provider also gives you some sort of. Actually, I think I had a picture where I wanted to talk about it, cloud provider API. Yeah, that was a. So they all give you some sort of a scaling mechanism. It's an add-on service, or in some cases, like if you use any serverless function, right? They're all scaling up and down based on whatever the provider is doing, right? Because when you're not using it, you don't want to pay for it, right? So pay as you go, and so you also have to scale down. And using something like KEDA actually makes it independent of your the cloud provider, right? So that's a big because otherwise you are kind of bound to a lot of the processes, your DevOps, your CI/CD, all of that gets tied to your cloud provider. So yeah, so there is definitely. So this is kind of a independent of any distribution of Kubernetes. It works with. It's a CNCF project, graduated, so it's not something that is just managed by one vendor, one cloud provider or something, right? So yeah, that's kind of the big differentiator for KEDA. So does it make sense? Why would you need KEDA?
Yeah. You say KEDA is Kafka.
Oh no! I think I gave a wrong. That was yesterday.
You correctly. I thought I did, but I want to make sure.
That was an example. Actually, there are 64 KEDA autoscalers. Kafka being one of them. So.
And the other question I hope you're going to address is HPA has always had a problem scaling down, right? Because the rounding formula never lets you really scale down effectively unless you drop to zero.
Yeah.
Are you going to address how KEDA maybe helps solve that problem?
I mean, HPA is HPA comes down to 1, and actually it also takes more time. And there are some reasons for that. The formulas are there for a reason. There's a lot of discussions that have happened.
Yeah, you don't want to be bouncing around. I know.
Yeah.
In practice, what I saw at least, and what other people working in other areas saw also was, it never really effectively brought it back down to a base level. It's just because the way the formula is, the math doesn't work out, and it just can't reach that floor.
Yeah.
But we want, as you point out, we want to be able to scale down to zero maybe, because we don't want that cost. We don't have any active traffic.
Exactly.
Okay. So you can talk about that more later. Great.
Yeah. So scaling down is a really big deal. Okay. In fact, now everyone expects it, but it was a big deal a few years back. Especially the early days of cloud providers, because everyone was like, oh, this is a new shiny new thing, everyone is on it, and then they see the bill, right? And then they realize that, okay, you're running so much of stuff, and that's when they start, questioning the choice of what they did, right? So, I mean, all this serverless all this stuff came from that, in some ways, scaling down, because that is a hard problem for a lot of, and it was not the incentive for a cloud provider is to keep it up, as long. So there is
show you my bill. I know that.
Yeah. So there is an incentive mismatch for them, to. I mean, it was a feature that was added because people were complaining, right, for the cost. So it has happened over a period of time, and everyone expects it these days. But you still have. I recall maybe early, like over 10 years back. I used to be very conscious about not running my AWS clusters or EC2 instances, and I used to have a Firefox plugin which will tell me what is running, and I stop it as soon as I'm done work and so on. and somehow this thing would create multiple copies of the EBS. It will just create a snapshot of the EBS, and so I'm scaling it down forcefully, right? But it's still keeping some remnant. So at some point my storage cost was high. So I showed up as like one of the top users of AWS in my company. So I had to call up AWS and I'm like, okay, what is going on? I'm being very, I'm not just like running it and so then they gave me $1,000 credit right away. This is a few years back, right? Now they probably will haggle, but and then next month again, I'm still on the top 2. So what is going on? My boss is like, shut your account down. It's like, so there are a lot of these things that they have over a period of time fixed. So it's not just the instances running. There is a whole bunch of other infrastructure that all can add up. So this is a very simple EC2 instance. It's like literally running like a VM, and I'm paying a lot more than what I was actually using. And a lot of times people don't pay attention to that, especially when it's a corporate billing, and you're paying only when you're paying 10 million to 20 million. That's when you realize, oh, there is something going on. Right? So those are the scenarios. So scaling down is definitely was a problem and is still a problem to a large extent. And again, addressing the exact scenario, right, the HPS scenario. There are actually reasons why they don't want to shut down right away, because this tearing down is actually has some costs, and if there is a request coming in, you want to again bring it back up. So it does wait for a little. Those formulas are after some thought they put all those reasons, right? So it takes about 5 minutes roughly for HPA to bring it down.
So like hard brake on the car, you just don't make hard brakes on the car, right? So just stop slowly.
Yeah.
If you hard press your brake.
Yeah. Right. I mean, a lot of new cars, they'll try to shut down the IC. Yeah. If it's an electric vehicle, they don't even want to use the brakes. So they all try to do efficient use of energy these days, right? So same concept in some sense. But yeah, the HPA I think does take time, because you don't want to, so let's say as soon as the requests are stopped, if you tear it down and then there's a request that comes in, then you have to again bring it back up, right? So yeah, so it's similar to I don't know if you're familiar with the serverless architectures. There used to be some people would always have a ping service, so that there is always at least one node, one instance of the serverless function running, lambdas running. I mean, so that way you always you don't get hit by the cold start.
Yeah, I absolutely agree. They're all based on time series metrics.
Yeah.
And I think the concern that I've encountered at least is that you didn't have enough control as a user of the system. You didn't have enough control over what that time series was. Right? You were kind of locked into Kubernetes built-in ideas of how long those gaps in the lake should be in terms of it's taking actions on your environment. So again, I'm just really interested in that. So
Yeah.
talk more about it.
That's a very interesting topic as well. So there are so Kubernetes by default has an API server with all the metrics and so on, right? Kubernetes HPA metric. So that's how it actually looks up all the CPU memory. Everything is tracked that way, right? So these metrics can be, I mean, these are metrics coming from Kubernetes. It keeps track of metrics on the pod, resources, and all of that. You can also have the metrics outside of Kubernetes as well, and that is where Kubernetes doesn't know that, right? It knows about everything about itself. It's a self-contained metric server, all of that within it, right? So when you have, let's say your Kafka or let's not just talk about Kafka. Don't want to give that impression because there's 62 or 64 actually. So the idea being, and actually, if you have time, I have an extra credits all the way. So if you seem like you have a lot of interest, which is good, because I'll tell you how to write a autoscaler on any system. So that is if you have enough interest. But the idea is you could have a metric server, so you could have a your Prometheus server, you could have any sort of metric server, so there out of these I didn't list out a lot of the other metric servers, you have all these cloud providers, right? You could have CloudWatch metrics, you could have Datadog, Neuralink, Splunk, you name it. So there is a whole bunch of those that based on the metric that you watch, the autoscaler can kick in additional trigger the resources, and you can scale up and down. Add more resources, or add or remove parts. Yeah. But these are good topics to discuss. I love the interaction, because otherwise, this is just a more of an intro subject, but based on what your interest levels are and interaction level is, we can go further. So basic idea, I think you guys get it, right? It's CPU memory, and it's beyond that. Okay. This is why it is the talk is Kubernetes ++. Okay, so we already covered this. So yeah, there are lots of use cases. I just took the retail example, but you guys work in different companies. You guys all have your Black Friday event, right? So yeah. So the two main things, so it deploys a agent, and it deploys its own metric server, and that is what is, I think, keeping track of. I'll talk about in the architecture as well. So it also works along with HPA. So that's another important thing to realize. So there is HPA and there's KEDA, right? So you don't want it to conflict with each other. HPA is trying to do its own thing. KEDA is that you might have. So it is something that works with HPA. And yeah, I already talked about the last part, so we are good there. So this could be any sort of your message queue. It could be database. So it could be like what do the DBAs look for? I'm just trying to come up with something.
Incoming requests per second on a service would be an interesting metric.
Yeah, so things like that, yeah.
TPS, transaction per second.
TPS. Yeah, transactions per second. Different databases have different, like system table you can query and you can get those. They want to make sure that the database sessions do not want to go over 1024. If this is, you can start triggering additional, rack clusters, or SQL Server, or Postgres, MySQL, all that is all covered. So yeah, below all of this is all those databases as well. So and it could also be a generic metric endpoint. So it could be something in the cloud, right? So in fact, that is what I'm going to show, in the extra credits. So any questions? Or I can continue.
So we can just, you said that you're going to show it, but does that mean we can have our own custom event producer, just for similarity, producer that going to trigger and let KEDA know that you need to honor this as a decision making procedure on our scale, right? So
Yeah, that is definitely an advanced topic. Writing a autoscaler is a bit of an advanced topic, but at the same time, yes, you can actually write it. The idea is if you write it, so what would be an example for in your case? Do you have
let's say similar thing, TBS, I'm expecting huge traffic, so
Yeah.
I expect that everything has to be
So more than likely it will be one of the 64 autoscalers.
I've got an interesting for you.
Huh?
Say I've got a new product launch at the beginning of April. So I know I'm launching April 1, and I'm expecting my traffic to exceed the norm substantially for at least 2 days. Can I write a trigger somehow that is sort of calendar based that says I want to scale up at this time,
Right,
and then
based on
not
a
scaling
campaign.
down until this time?
Scheduling, right?
Yeah, that's more like a
It's kind of
scheduler.
a fun
Yeah.
schedule.
You can do scheduler, but I think it's more efficient to do something which is more resource based, right? Because then you're not even, those 2 days, when the 2 day starts, when it ends, when there's peak, all of, so the whole point of using something like Kubernetes is you don't have to think so much, or you don't have to schedule so much, you don't have to plan so much. You plan, you declare that I can go up to 30 nodes of whatever your name your choice,
Yeah, I was just trying to explore sort of what the limits
Yeah,
of
yeah,
what
yeah,
those triggers could be.
Yeah. So the whole point of this is all highly cloud native, highly available, scalable, up down, without you be hands on the keyboard, right?
So like with say I don't know, a shopping cart or something, would you be looking at like, we know there's a time between a visitor coming in and then going to check out and needing to do whatever processing there, so you might scale up those services based on the number of folks coming in, or does it need to be more, like if we've got this many events of folks coming in, we start to scale up because we know traffic's increasing, or would you want your events to be actually, as they're hitting the checkout, those kind of events are what's driving more, whatever's running your payment processing, for instance, to scale up?
I have a demo just for you, but I don't know if I'll have time for
Was this a setup?
I take Venmo.
So there are so many different variations, right? In just that example, so you have the web front end. It is going to hit some front end cluster, right? And so if you have a large web property, there is going to be things that are, you have millions of users. It has to have a bunch of nodes that you really cannot predict, especially if there's no time zone limitations and so on. So you really cannot, the scheduling becomes quickly out of control, right? So that's the front end, and then you have, that's when you come back to that Uber picture, you have things that are a bunch of services behind the scenes, and you don't even know what are all the services this particular request is going to come in. Someone is requesting, let's say you go to Amazon. This is my favorite example. COVID time, everyone is looking for toilet paper. And people are running helter skelter. They're all going to every website. Amazon was getting 1,000, million requests for toilet paper, and you can't, it's run on. So people who are not getting on Amazon, they're running to Costco. You have lines standing there, right? Everywhere it's people are running out of it, right? So how do you, so you can have surge pricing for toilet paper, right? I mean, you can do all, this is exactly what Uber was doing, and we were all, what is this going on? We need to have regulation. This is not free market. You can do whatever, based on the requests that come in. So how do you, handle all these requests? And that is where you need this kind of highly scalable environment, right? So I can actually do that demo, but let me first finish this, and then there will be extra credits because that is a beautiful root cause analysis of a scenario where someone is doing a checkout and everything looks good. They're going through orders and they hit this. They put in the credit card address and they press checkout, and then they're not sure. There's a bit of glitch. They think it takes time, and then they're not sure. And then it says it all went through. So now you're not even sure if I got my thing or not. Should I call customer support? It will be another request. Then it adds up more loads, and so it quickly kind of goes into a snowball effect, right? So that is where you need, and that's why you say use a cloud environment. You need infinite scale, but everything has limits. No one has infinite money. So, so yeah.
It's also the old, it's twice as hard to debug anything, so don't
Yes,
be too clever.
Yes. So you have so many components, and these components are running on so many infrastructure components. So you get to a level of complexity that you need some better tools. Right? That's kind of the. I think we went through this a few times. So this is again, we have half an hour, so we can. So it's a. I can actually go to the websites. So this is the actual cloud native. So it's been in graduation for a while. You can visit the project website. It's got pretty good. So it's got a lot of backing, a lot of backers. That's why it looks very professional, right? Because you do have a lot of professional developers on this too. It's not just all part-timers. And what is the website? And then that is the one that I want to close that. It's completely open source. So there's a bunch of so there's an operator. So you have different modes of working with Kubernetes, right? So the Helm charts, they are the most popular. They're there. There's you can contribute to KEDA, very open system. They have I think a weekly meeting every Tuesday. They have SIG meetings and very active community. Bi-weekly actually. So and these are all the end users. So they have big names. Microsoft is also a big, contributor. So Azure, all the Azure Service Bus, Azure Streams, Event, all of them you can use with KEDA. Yeah, so Azure is a first-class support. Red Hat is also very active. Okay, so I'm actually going to show a simple demo. Actually, I have a bunch of Kubernetes environments on my machine, and none of them worked just before the demo. So I reselected my Minikube. I stopped using Minikube because it takes up a lot of resources. I was using Kind, a bunch of other, like the desktop, what's a Docker desktop has a Kubernetes. There's too many variations, too many, micro-K tests I had. All of that. Finally, sometimes when you have to do something, and I had done this before, right? So I'm like, okay, so let me just go back to square one, right? So I did Minikube, and what is your choice of Kubernetes distribution for development? Kind. Okay. Anyone else?
Charter, you're on VMware.
VMware. Okay.
I worked on dev tooling at Outreach for a while, which had a big dev team, and we used Kind to deploy to like 300-400 machines all pretty much constantly.
Yeah. So Kind is a way to go because Kind is a least resource.
And it has nice integration. Like if you want part of your infrastructure to be cloud-based and part of it local, so that you don't have to spin up everything locally. So that's really nice too.
Yeah.
I've always been a fan of K3D. That's for just locally playing around with stuff.
Yeah. I use that too.
Yeah.
I use multipass recently.
Multipass has that too. I have multipass already. Yes. So I had so many of them, and then none of them working at the time. So it was like,
most people know I'm building a cluster in my apartment.
okay.
And I'm planning on either K0s or K3s.
Yeah, K3S is
K3S,
actually
yeah.
also another.
That's
So
what
so
I run.
yeah.
Yeah.
So kind, of course, is the Kubernetes and Docker, right? So you can do anywhere, right? So that's kind of, once you have a Docker environment, and Docker itself sometimes, I have too many environments. So finally I stuck to Colima today. Colima worked for me. So
Yeah. And if you're using K3S and want to do a cluster, um, K, wait, it's a project called Catch Up, but it's K3S Up. So catch up. I don't know, but anyway, but yeah, but it's a convenient way to like connect them for all the networking, join the cluster, and all that good stuff. So might be something to look into as well.
Like
Yeah.
Pi is like on your laptop.
Yeah, yeah.
Yeah.
okay. So I'm actually going to a little bit of walkthrough is probably no, still not. What's going on? So let's see. So this is a KEDA website, and I'm actually going to. So there's a whole bunch of. Yeah, let's actually go through the website. Um, oh, am I sharing my screen? Yeah, you can see it. Okay.
Yep.
So there is, you can see all these scalars and all of that. Now I am going to use the one of the sample examples. It's an old one. It's been around. All that it really does is So yeah, you definitely need Kubernetes, right? And you need KEDA installed. So yeah, to instead of writing all this on a slide deck, I think it's best to go through this. So there's a Helm chart deployment, and yeah, these are all self-explanatory. You guys can do this. So I can just install. Okay. I think I already just let me just. Okay, I did this, so it's already there. I did it just recently, by the way, just before I came up. Delete it. So all I've done is I have a Kubernetes cluster Minikube with KEDA, and so I'm let me make sure I deleted everything because I want to start from scratch. Okay, everything is deleted. So if you go to my Kubernetes, this is the Kubernetes. Nothing is there, right? Okay, everything is clean, and yeah, these are all good things to when you are demoing. You can. Otherwise, everything is automated. Everything is so nothing to see. Right? So I am going to set up this RabbitMQ Helm chart. So what it's doing is it is deploying RabbitMQ, and actually let me show you the repo. So we are so we have a publisher and we have a consumer. So now I'm going to deploy this consumer that is going to consume messages. The details are not that important. We want to just make sure. I mean, can you guys see this first of all? I mean, forget about details. Can you read this? Should I increase the font size?
It's a little better.
So yeah, so it's a consumer publish combination, and now hopefully my yeah. So I have my RabbitMQ that is running. So if I click on this, this is the RabbitMQ that is up and running, right? I just deployed the Helm chart for RabbitMQ. Now I have it running. And if I come to Kubernetes, you can see, I just deployed the RabbitMQ pod. Makes sense? Now, next thing I'm going to do is so I'm going to just open another tab. I think I have already too many tabs. I'm going to start one more. And the next thing we're going to do is, so I got that running. Now I'm going to, okay, first let's check the number of, if the thing is, so RabbitMQ pod is running, okay, 1 of 1. Now, this is what we are going to do next, right? So let's first look at it before, because I'm doing a demo. I'm not just, I mean, you guys can go home today and do this 5 minutes, literally. Okay? So I'm going to take 15 minutes to go through this.
My bank account? Yeah, I'll do that at home.
Yeah.
So yeah, so what it's doing is it's setting up a consumer, right? So we'll do that. Deploy consumer. Okay. Now when I look at the pods, now I have a RabbitMQ pod and I have a consumer pod, right? Describe this. Not resource type. I think get pod. This is a default. Okay. And actually, before I did that, I should have showed you this. So this is my. This is what I was talking about, right? Again, let me increase a little bit. So you have this is the optional piece, the webhooks, but this is the main thing, the API server and the agent, right? So they have the metric server and then they have the agent. So I should have showed you this because that is what you're actually doing. When you do this, the deployment of the KEDA is essentially a Helm chart, right? So when you do this, so if I look at my namespace, KEDA, right? I see my KEDA pods, and then I have in the default namespace, I have RabbitMQ running, right? So so here I'm also watching this defaults because this is a quick demo. You don't want to miss it. And so now I'm going to yeah. So we already did this part, I think. So not this one. So I'll keep this aside. This is the that is running. That is RabbitMQ and the consumer. And are you guys following this, or I'm just talking to myself at this point?
It looks like Docker Compose, but less bad.
Yeah.
So because I got permission to use Docker at work, but not Kubernetes.
What's that?
I got permission at work to use Docker, but not Kubernetes.
So Docker Compose is another orchestration.
It's not that bad, but because we don't need to scale it, but
Yeah. Right. It is. I mean, Docker Swarm is the equivalent of Kubernetes, but Compose is kind of, you get to write a declarative way of running a bunch of containers, right? So which are all dependent. You can add some. It's like a makefile. Right?
I think Compose is intended to be used with a single instance. I thought Compose was meant to be used with a single instance.
Yes, I mean people use it more on the like test, dev, those kind of things, right?
Yeah, I wouldn't run it in production ever.
Yeah.
It's not.
We are.
That's scary.
So here is your consumer. Here is the RabbitMQ. Here is Docker. Here is I think I'll close this one. I don't think we need this. And is this? Yep, there is. I'm watching this, and get deploy. Okay, so consumer is there. Now we need to pay attention here because this is going to go quick. So I deployed. So I'm publishing. Okay, I published it. And what does a publish do? Just to make sure, remember what it is. It is publishing this client. And the client is sending a whole bunch of hello worlds, greatest program, right? And as it's sending a whole bunch of hello worlds, here is a demo. So now it is flooding hello worlds into the RabbitMQ. So KEDA is now starting up more and more consumers. So
There you go, moving off camera again.
oh, sorry.
There we go. You're good. Now you're back.
So I can still have the effect. Whoa, look at that.
Sneak off for a pizza and look what happened.
So actually I have a max of 30. Okay. So when it hits 30, so that's, and this is something that you guys can go home and do this on your own, right? And then now it starts climbing down, right? So it stopped messages and it stopped processing. So this is something you literally can do in 5 minutes. Okay, there is nothing stopping you from not running this in 5 minutes. So what did we do again? So this is the HPA, and so just to make sure we understand what we did, we went through. This is for the build. This is for the receive. So it is receiving. Yeah. So I send a whole bunch of hello worlds, and the consumer gets deployed, right? And the publisher is running with the username, password. So actually, we could have also seen all this stuff while we were processing it. I can run it again just to see how. Where is this? Publisher deploy. It is on, but let me change. So I applied that. So let's make sure. Oh, so yeah, it is. Yes, so I think at this point we also have. So this is the Kubernetes environment, but I think this gives you an idea that it actually does work. Okay. Now the next step, that since you guys are here and we can, I have a bunch of extra credits because you still are here. I am going to now show you something more interesting, or it may not be interesting to you, but
Quick question on that example.
Yeah.
Is KEDA using the same limits as HPA? That's why you're looking at the HPA limits to see where we went up to, so they kind of share the same boundaries.
HPA has different deployment file. KEDA has different. So.
But when you were checking the limits there, you were calling HPA.
HPA, yeah, because I was looking at HPA because it uses HPA to do that scaling up and down.
Got it.
Yeah. So actually, I think I should show you that again. So, those are the CUDA ones, and then the default ones for the RabbitMQ publish. Okay, so that is that. So I have actually a scenario where so this is some random metric where it just goes up and down, and I'm watching this, and how do I watch this, and based on that, how do I write a scale because that is what, remember we had that scenario where, this, let me actually show you the, so it's looking for this metric, and we, let me actually go to another environment. I'll make sure I'm logged in here first. Oh, I'm not logged in. So,
Out of curiosity, since the example was using RabbitMQ, has anybody done any kind of programming with Erlang by chance? I'm just kind of curious.
Is WhatsApp still in Erlang?
I don't know.
It's an Elixir in the past, not
Okay.
running directly though.
Yeah, okay. Yeah, I was just kind of curious. I never messed around with Erlang at all, and I know it's just
you are an
it's
Elixir guy, right?
solid in
Yes,
for
yes. I
RabbitMQ.
remember you. You did an awesome presentation
Thanks.
back in, where was that? I think it was in the Cortex.
Yeah, thank you.
On OTP, and Elixir and all that. Yeah, I remember you. Yeah.
So you're saying we have a future speaker
Yes.
here?
I can show off JSON if you guys are tired of Helm charts.
So here is an example of a very so this is a metric server that I'm doing a query looking for that remember we had this chart where this metric is going up and down, and I'm actually so this is the actual metric name, and I'm looking for that metric and I'm querying it looking for the min value. There is a trigger that so this is actually instead of going in there, I can also show you from here. It's So this is what I was referring to, right? There is a whole bunch of scalars, and the one that we were looking at, I think I have a fairly recent version here, so this might be easier to read, just for. Oh, this thing doesn't scale. Okay. I hate the. Golden doesn't, the IntelliJ ones don't do the control plus plus right away. You have to go and do it with preferences. Can you guys see this, or it's too hard to read? It's hard to read. It's hard to read for me. So, where is our preference settings? Can you change this side? I need to change the other side.
Might also help to switch to a light theme.
Yeah, from Darkula.
Or I can do
This is better.
Oh, there you go, high contrast.
okay, and this no, I think we need to increase this font size. don't know, I can even do presentation. That's fine. There is a way to get to presentation mode, right?
Yeah, or else there is the, let's see.
Enter presentation.
If you click, if your focus is in the code window, you can do, then it'll show view,
Yeah.
active editor, and then you can do increase font size.
Yeah. What's that again?
Or I'm sorry, do shift, wait, control, shift, and then dot to increase in all.
Okay, perfect.
Yeah, and then comma will reduce.
Okay, all right, perfect. Thanks.
Mhm. Yeah, I remember there was some funky key combination.
Yeah. So there's a metadata for, so there you can put in all your API keys and all of that. So this is the query that you're writing. So you have to write a query result, get metric. Okay. Get metrics and activity. And so I'm actually introspecting that querying that, and one of the things we found was when you actually try to run this, so they have a whole tutorial on how to write a scaler, how to build it and all of that, and I can show you that, but the key thing is if you don't run, you have to build it into a container image and then run it as a pod, this scaler. Otherwise, Kubernetes is very picky about network and secrets and all that stuff, right? So if you try to when you're developing and you try to run it on the command line, it won't work. So something to keep in mind. So you have to go through the process of actually deploying. And
So you're saying we should also use Argo CD in that?
whatever makes it easy, right?
That's for another talk.
Yeah. So actually, I forgot exactly what. So anyway, I think the demo that I was going to show. Let me first show the demo because that will make it easier to. The thing is, some of these demos are not very wow factor. You have to look at, oh, did it go up and down? That's it. So yeah, I mean that's why you have to look at the. Maybe I should have showed you the the Kubernetes chart when it actually or the console.
But that's the whole premise on Kubernetes, right? Anyway, is that you shouldn't have to worry about anything. It's taking care of it all, so it should be boring.
Yeah. Scalar.
I'm curious. Have you tried playing around with the Redis scaler?
I actually did a while back.
Because I'm wondering. I mean, I'm assuming. Is it based on like querying a value in the Redis cache, or?
We can look. Actually, there is an example right out of the box. I mean, I don't want to do this in front of you, but you can try this. When you,
Yeah.
I mean, if you are interested, we can try it now. But yeah, but there is a out of the box example. So, which is a combination of MySQL and Redis. Running this shouldn't be that hard. And I had run this a while back, so I can try it again as well. So, let me first. This is all the RabbitMQ stuff going on. So yeah, let's just keep that aside, and I'll run this right here. So, let's go back here. You guys are following me, or again, am I talking to myself? I should go slow, I think. Yeah, so I got that.
I have a question. So I haven't used Kubernetes. I'm not really a cloud guy.
Yeah.
I mean, I'm not against it.
You're a
just-
Docker
I-
Compose guy.
Yeah, so why would you use something like KEDA instead of, say, Lambda or OCI functions? So why bake the serverless architecture into a framework or tool instead of on top of the architecture, on top of the cloud?
So I think out of most people, I think I mentioned, they are not using straight stock Kubernetes. They're all using a distribution of Kubernetes. So especially if you're using, you're already on the cloud, good chance you're not running your own Kubernetes cluster. Let's say, take an example of AWS, most widely used, right? So some people, the bigger companies might have the wherewithal, or they have the abilities to, they have the chops to run their own distribution, and they want to, if AWS raises the price, they can go to GCP, they can go to Azure. So that is the right way to think about this, right? Because you want to have control over your infrastructure, but you also want to have infinite scale with the cloud. To answer your question, right? Because I kind of little went sideways. There's a good chance you are not using, you're using a distribution, not stock Kubernetes. And when you have a distribution, they also come with a lot of bells and whistles. And bells and whistles include autoscalers. AWS has its own.
I was thinking don't give Amazon or Oracle any more power over you than they already have, but that makes sense too.
Yeah, so it's a kind of a push and pull, right? Why do people use the cloud? Because they don't want to have people managing the data centers. Now why are people complaining about AWS? Because they charge cloud prices go up. So you have to manage all this stuff, right? So that's why they give you additional tools. So when Lambdas came, everyone is like, no more servers, serverless, right? That is the marketing tag. And again, we talked about all the scaling down issues and so on. So they give a lot of tools for this kind of, EKS is probably the most used. So there are some companies who use EC2 instances, or ECS is cheaper than EC2. EKS has some additional cost, but you get additional benefits. So it's a very complex pricing world. So you have to think about, finally it comes down to how do you save money and how do you run your application and your the best value for the best money that amount of money that you have. That is essentially what it comes down to. So when you use something like independent tool, like which is not tied to your cloud provider, then you have more leverage, right? Because then you can leave, you can take your thing and go. But if you are tied to this, it's harder, because then you have to invest more time and resources to. In some cases you cannot. Even if they raise the price, you have no choice, right? So because your infrastructure is, or your applications, your business is tied to it. If you don't have, if you have the toilet paper scenario and you're not able to sell that, your business is going to lose the customers. They'll go to the competitor, right? So you want to have a scenario, a situation where you are in control and you use things which are independent of. Oops, did I lose? Are we all in? I'm still.
No, it's need to reshare it. Yeah. Yeah. Lost it.
For 1 minute I've stayed until
All right, here we go.
back. Okay. So
We're back.
to answer your question, actually that's a very, very important question. The whole point of all this is to save money and to serve more with the money that you have. Not, that you need to go ask, your boss for more budget, because now I need to, or you'll have to start scheduling things and managing all this stuff. And the whole point of all this is so you can sleep better. You can make more money, you can sleep better. That's the goal. No, I mean, kidding aside, but the idea is not to be tied to a vendor-specific scaling solution, or there's a whole movement, right? Knative and all of that. Is also, I think that's another talk. Did we already have a Knative talk? I think we did, right?
Maybe when Sabri was, it would have been pre-COVID.
Yeah.
Yeah.
So, but of course, the lambdas are still the most popular serverless out there, right? I mean, Azure Functions, GCP, and they also are. There's always a push-pull. They make it as competitive so that you are going to use one versus the other, and if it, I know lambdas, for instance, they scale up in some batches. So you end up getting a whole bunch of lambdas that you may not need, and scales down slower. So you still pay for there's like subsec. No, I think it's like they charge you by milliseconds. It's a very very granular, but it stays up. Network costs, all of that add up, right? So there is you could quickly have to be a spreadsheet expert when you're running things in
There's
cloud.
a push to go back to self-hosting.
Yeah.
Thanks to Hannemeyer Hansen, right? Yeah.
And that is a very controversial topic, right? I mean, he's got his own distribution.
Yeah.
But yeah, it is, and he's got very few people. I don't know how he does that. I mean, realistically, it's very hard. Even if you have rockstar engineers, it is not easy. 10x, 100x will not do it. As simple as that. It is a problem of different scale. So actually, yeah, we are still doing the Redis, but I think I'll leave it as an exercise. And actually, the scaler I'll also add the documentation on how to write a scaler, because just showing one doesn't really help you. And you already have seen the RabbitMQ does work. I'm not talking through my hat. It does, yeah. Now the scenario that I was actually talking about, which okay. So here is a scenario where someone is going, and I'm sure, I think this comes from again a 10-year-old demo app that Google had, and lots of different variations of this. It's a microservices app. Imagine you're running it in your bare metal, you're running in cloud. End of the day, it's an online app, right? And you have hot products where I go buy some of these products, everything looks good, I'm adding to the cart, I keep browsing. I'm sure you've seen this, right?
Mm-hmm.
Add my favorite vintage typewriter, because I gotta do my writing, 200 words a day, and I'm gonna put in my information and I'm gonna place the order, right? So everything looks good. I'm placing the order.
Who wants to use their credit card?
Yeah, I should have asked. Okay, so the order completed, but it took a bit of few seconds, right? Which is not very, this is a common thing that we have. Sometimes it is fine, sometimes it's not. And now we are not sure if it went through, but it seems like it says it's a confirmation ID, I have a shipping tracking ID, but what is going on? Cost is 0, something is not right. Do I need to call? All of that stuff. So I can actually show you more stuff, but again, these are all extra credits. We'll go to that later. Okay. so I come here. So this is my front-end application. Actually, I can go straight here because you already saw some of that, right? So this is my front-end application where I'm seeing how the page views are coming in. Actually, I did not remember the URL. I went in from here, so that's why I kind of gave away some of this stuff. So there are page views, page load times. You see how they are fluctuating and all of that. And I can see this checkout time is a little trending up. It has been going up, and I can see you guys are all Kubernetes guys, so no core web vitals don't mean anything, or does it? Okay, so there are a lot of so those are all front-end metrics, browser metrics. There are a whole bunch of them, right? So there is yeah. In fact, for an SRE doesn't care. They come here, they look at this, and they're like, oh, there is some trends, there are some errors. Oh, there are some errors. I see some errors. Oh, this is why the price is not showing up correctly. That's it. They don't want to analyze too much. It's like because they have so many. They are busy. They cannot. They didn't get good enough sleep. All of that. Right? So, so they see this and they're like, okay, that's something red. Or there's some poor thing here, poor performance up, down. Yeah. But in any case, if they're a SRE that comes in and sees this stuff, and they see there's some red squiggly things, and this maybe someone who's more knowledgeable can go deeper, right? You can see the input delay, cumulative largest content paint. I mean that's a different talk. Okay. Yeah, there is a whole hero image and all of that stuff, right? The whole web, and we can extra credits will if you guys are here. So I'm going to start with this checkout because I know checkout was slow. So I hit checkout. And I see that the checkout is indeed slow at times. There are certain times where it is really slow. P99s are 9.12. I can see that some of these are pretty. So I can actually just look at the bad ones, and I can see the type of browsers. This browser is a little faster. Chrome is a little faster than Safari here for this application. And I also have all the sessions, right? I'm collecting all the sessions, web sessions. So these are obviously browser sessions coming from the wild, right? So if you look at these, I can see these, different countries, regions, blah blah blah, URLs, all of that, right? So I can, if I get rid of this. I can see all of that analysis, right? Because it's coming from so many places. So the idea is, you can see the like AU the percentiles are higher. So what you're really looking for here is the user session, which has taken a lot of time. And I'm going to look at this user session that is taken 9.2, right? The large one. So we want to. So this is an SRE job, right? If he wants to quickly know why is that. People are calling saying that my I don't know if the order went through. I'm getting some zero numbers, and I'm not even sure if it went through. So they come in here, they look at the web session, and they see that it took 9.2 seconds, and I can click on that and I can see, oh, it's actually on the backend, so out of the 9.21 seconds, most of the time is spent on the backend service. So in the backend, I see that it's a service application that takes up 72%. Database is less, external services are less, network is less, and then I see that there is some errors also coming up. Okay, so now I already know. Okay, I need to look at this checkout some more. I can click on this checkout, and this takes me to a service map view, which is the view of how the request came in from the front end, hit the checkout service, hit the payment service, and so on, right? So this is already, like, yeah, this is not that big, like what we saw in Uber, right? Uber was huge. If I remove this, you'll see that, there's, yeah, this is the old Google's microservices demo, right? There's a bunch of services, but not crazy, right? And I'm going to look at the checkout, and the checkout says that I have some errors. And now I'm going to break it down by different, I can do it by different tags. Right? So this is again, now the SRE knows this is an error, right? I mean, we already saw, we had an error here. We want to see why that payment service is erroring. Is there something wrong with this external payment service? You want to see if the service is affecting, people are calling in, is it affecting all, it seems like all kinds of customers are getting affected. The blast radius of this impact is everywhere, all across. And there was a deployment that caused it. Hypothesis, SREs always go by hypothesis. So they go look at versions. I mean, you can slice and dice by lots of different things, and I see that, version 3.5.10 has a bunch of errors as opposed to 3.5.9. So, okay, this is what it is. Let me quickly go back up the version. So I revert back, and I continue my analysis. And what is the analysis? We got all the errors in this. This has got no errors, and this has got all the errors. So now this is a bit of observability, because this is traces. This is when we start coming into traces. So I'm looking at these traces, which are all these error traces, where your checkout service failed because this payment service error. Right? For this particular version, 350.9 did not have any errors. This one has errors, and if I click on this, I actually see the entire trace of the request that went from checkout, hit a gRPC to place the order, get the things in the cart, and blah 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 blah, and then get quote, finally hit errors on the payment. Right? So this is an unknown error, and I can see all these. These are tags that I'm collecting from the span, and I can actually have a bunch of tag spotlight. It's very similar to what we saw on the front end. You can see on this payment service as well that version 3.5.10 has all the errors, right? And there are a bunch of other tags that are just slowly showing up, but you will see that all these things that we saw there as well, right? So this is all, these are all the metrics that we're deriving from these spans. And you have, custom metrics and so on. These are all application stuff that you can, build to make sure that your application is running and you can do the root cause analysis quickly, right? So we saw this part. We can also do the look at the endpoints, how these endpoints are working. So let's look at the currency service. Has got a bunch of things going on. Shipping service has multiple endpoints. I can look at all these. I'm actually looking for Redis here, and I can trace logs. So these are all the logs for that specific trace, and I can see that there's a bunch of them. There's a lot of logs and lots of, this is the details of what we saw, right, in the error. All this is coming from the front end. Remember, we are doing the checkout. So I can do this by all these other dimensions on this metric. It's running on the Kubernetes environment, so I can do by pods, node names, all of this stuff, right? And I'm going to group it by severity, so I can see this, and I can quickly look at just the errors, because that is what was happening. So 350.10, the version 350.10 has an invalid API token. So someone deployed it with a wrong API token. And if you see that there, it errored out a few times, and then it went back to let me remove this exclude from filter, and it went back to. So if I remove that filter, I see that it actually went through fine. After a few attempts, it went back to 350.9, where it processed. So you had a cluster of payment service deployment with some of the pods that were on 359 and some were 350.10. So new version was also getting hit, right? So when that was happening, you are getting errored out, and it's like a try catch, right? So after a few times of 350.10, it hit 359 and went through. So that is why your checkout was slow. Now it's a very hard problem to solve. The SRE has to quickly figure out, because the harder the problem is, longer it takes, more sleep is going to lose, business is going to get impacted and so on. So that is the.
Do you have to worry about that slowness depending on how you set up those events, triggering your autoscaler, and then you're like paying to compensate for a bad deployment? Yes. So that is to the long story is come back to that. Right? so if you go back here, so here is the infrastructure for this. Let's go back to the payment service, because that is the one that we had problems with. Okay, that's fine. So the front end demo service here, actually right now all the nodes are healthy. Right? I actually have another scenario where the nodes go up and down, runs out of memory, and it keeps crash loop error, those kind of things. But yeah, basically the idea is you want to keep your nodes and the pods in them healthy, and if not, it has to make sure that you have your deployment that you in your manifest, or whatever you declared. So you want to keep it in that range, and it should automatically take care of the errors, and it should automatically scale up and down. Right? So that's kind of the basic, even for that scenario, right? The checkout scenario, when you have lots of users coming in. In my case, I did not really show you that. I mean, there is a locust running, and injecting a lot of traffic. I have I have some synthetics also that is sending all this traffic. So based on synthetics, it's telling you how much time it's taking for all these requests. But this is actually the entire end-to-end, right? This is not a synthetic. This is a real user, right? And now that we are 8 and you guys are still here, I will venture into the little more the esoteric parts. So so when you hit so how does it pick up all this stuff, right? So you have a agent that is tracking every one of these, and this happens on pretty much every modern web application. Not even yeah, of course. And it's not just the Googles and Facebooks of the world, right? It's they have kind of taken over the internet, but every company also wants to analyze how the customers are interacting, and if the checkout is not fast enough, all these things. So you have so this is a very simple example app, right? I mean, you can actually look for this online boutique on lots of versions, tens of versions of this. But when you actually, let me hit this site, right? This is a front end. So when you hit this, the hipster shop, they have all the CS
CSS, JavaScript, and all of these assets and all of that. Along with that, I have this RUM token. Okay, so the real user monitoring. So this is constantly sending every few seconds, it's sending data on how I'm interacting, right? And it also is tracking. So when I click on the lens, it went to another page, and it is, so every DOM element, it's actually picking up all this stuff, and it is, if you keep watching it, it is also sending it every few seconds. So yeah, just keep watching it, right? So that is how it is tracking the user interface. Now on the back end, so now so this is what is. Let's go back to the infrastructure view, right? Because that is where we were interested. Actually, where did our infrastructure view go? Yeah, I think I kind of went a little all over the place. So let's come back to the infrastructure view. So the infrastructure view we have the front end. This is just a front end cluster. There is a bunch of other container clusters, right? So we have so the idea being, you need to have all of them healthy. Otherwise, I mean, you don't have to have all of them healthy at the same time, because they might go up and down. But the idea is to have them healthy and working, so that your app is running all the time, and you don't have to get up and do this, right? So that is the idea of autoscaling and auto remediation, auto deployment, and Argo CD, and all of this, right? So yeah, this is just one component of all the other infrastructure tools and toys. So that's a long answer to your question.
So, yeah, we're about running out of time here, but
Yeah,
any other questions?
I'll just say I did find an answer to my question earlier.
Oh, which is?
While you're talking, I googled it. There is a KEDA scaler. They call them scalers, right? They're integrations. There is a KEDA scaler for cron.
For?
There's a cron scaler.
Cron scaler.
Right. So basically, you
Schedule.
can set up a cron, not a recurring schedule, but a single instance schedule. Say I want to scale up or scale down.
Right. Okay. So for like a campaign or whatever,
Something
like you were
that.
saying with your
I
example.
was just curious, what's the extent of it?
Yeah.
The scalar page was 50 or 60 different integrations that they have.
Yeah. Well, because you figure too, if your marketing folks or somebody is they're in another system, they're setting up their calendar, and if there's some sort of an integration to look at that.
I don't want to be up at 2 in the morning doing it.
Exactly. Yeah. You don't want to be the next. What
It's
was
all
it?
about
Coinbase.
You're on the right track.
Yeah. Oh. Well,
Okay.
cool.
All
All right. And again, I get to use the fancy new thing in the software.
Thank you for being a patient audience.